Hello and welcome to today's geometry lesson. Before we get into it, we're just going to review a couple things from math that you guys have worked on in previous years. So first of all, what is a ratio? And a ratio is a comparison of two things like miles per hour. So it's a comparison. And we can write a ratio as 1, 2, 3, 1, 2, 3, or 1, 2, 3. Typically in math, we do it as the fraction. So number 2, we always have to reduce our fraction. So we would reduce this down to 1 to 9. Now, what is the difference between a ratio and a proportion? A ratio is a comparison of two things. A proportion is when you set two ratios equal to each other. So like 1 over 3 is what over 27? Okay, and then we would solve these. Now, how do we actually solve them? So let's first solve my one I just made up. And remember, when we solve them, we cross multiply. So in this particular case, we'd take 27 times 1 equals 3x. And now we're going to divide both sides by 3. So we get 9 equals x. Some of you just kind of do this math in your head because you can see what the scale factor or ratio is going to be. And so 1 to 27, you know you're just going to multiply by 9. So that's what a lot of you do, and that's totally fine. But we also need to be able to set them up because some do not just jump right out at you, so you need to be able to solve it, like in number 4. We cannot just solve this probably by looking at it, so we're going to need to cross multiply. So we're going to take 35x equals, now multiply these together, and we're going to end up having to do the distributive property over here. So 35x equals 28x plus 28. All right, so now we're going to subtract 28 from both sides, and we get 7x equals 28. Now we're going to divide both sides by 7, so x is 4. All right, so ratio, setting two things up to make a comparison, always reduce. To solve a proportion, we cross multiply. All right, what we're going to be talking about now are going to be similar polygons. So things that are similar. They're not exactly the same size, but they do have characteristics in common. So remember, to be similar, they already have to be the same shape, but not necessarily the same size. So two geometric are figures if and only if there is a similarity transformation that maps one of the figures onto the other. So in a polygon, other than the fact that they need to be the same shape, what other two things must happen? And one thing that must happen is that corresponding angles need to be congruent. So corresponding angles are congruent. And then the other thing that needs to happen is that the sides are in the same ratio or the sides are proportional. So if one pair of sides is doubled, all the sides need to be doubled. All right, corresponding lengths. If two polygons are similar, then the ratio of any two corresponding lengths is equal to a scale factor. Okay, scale factor. And we typically go from left to right unless otherwise noted. So start with the figure on the left and go to the right. So if we go from here to here, this is getting bigger. So the ratio would be like 3 to 1. If we are going from this to this, now your ratio is getting smaller. So it's going to be 1 to 3. So unless specified, go left to right. All right, are these quadrilaterals similar? Well, first of all, we have to check, are all the corresponding angles? So we've got two right, single, double. So check, this one does happen. Are all the sides in the same correspondence? So let's compare the two between the two right angles. That is in the scale factor of 2. Okay, then let's just do the top ones. 6 to 12, that's also 2. 5.4 to 10.8, also 2, and 4 to 8. So yes, they are all in proportion. What is the similarity ratio? So we're going to go from the first one to the second one. So is it 2 to 1 or is it 1 to 2? Well, it goes from smaller to bigger. So we're going to say this similarity ratio is 2 to 1, or you can write it 2 to 1. And what is the similarity statement? And we can say quad. And let's just go A, B, C, D is similar to quad, and A corresponds to E, B corresponds to F, C corresponds to G, and D corresponds to H. All right, when writing a similarity statement, it's like writing a congruent statement. Make sure you write them in the same order. Alrighty, let's look at these two, and we are told that these two rectangles are similar and they have a scale factor of 3. All right, what's the perimeter of this first figure? Well, there's a couple ways to do it, but 6 plus 2 is 8, double that, and we get 16. And the area of figure 1, remember area is base times height, so 6 times 2 is 12. Now, if we tell you that we have a scale factor of 3, can you just find the figure of perimeter 2 without even finding the lengths of any sides? Can you find the area of figure 2? And most kids at this point in time say, yes, you can. So we can just multiply by 3, and 16 times 3 is 48. And then kids go on to say that we're going to do 12 times 3, and we get this area of this figure to be 36. Okay, and then kids just go on. So let's go on and prove and make sure that this does or does not work before we go on any further. So if we have a scale factor of 3, 2 times 3 makes this 6. 6 times 3 makes this 18. All right, so let's do the perimeter. 18 plus 6 is 24. And now if we 6 times 3 is 18, 3 times 2 is 6. And if we take, oh my goodness, let's go back here. I did not do this correctly, did I? 6 plus 2 is 8, and 8 doubled. Oh, I did do it right. It is 16. I thought I did that wrong. And now 16 times 3 is 48. So 18 plus 6 is 24, and 24 times 3 is 72. All right, so now that we have this perimeter is now 24 for that side, multiply it by 2. Whoops. And we do get 48, which is exactly what we got when we took 16 times 3. Okay, so let's do the area. So the area of this figure is going to be 6 times 18, base times height. So 6 times 18 is, wait a minute, it is 108, but we said that we thought it was going to be 36. Those numbers aren't anywhere near each other. So how do we go from the area of 12 to the area of 108? Okay, so what's happening here is we're multiplying this by 3 and we're multiplying this by 3. So 3 times 3 is 9. So what if we would have gone over here and multiplied by 9? What is 12 times 9? 12 times 9 is 108. And that's why you cannot just take the area and multiply by the scale factor. The scale factor is a 1-to-1 ratio, whereas area, just think of your labels. If you're doing perimeter, you're just going to say units. And when you think of area, you're going to say units squared. So you're going to have to take the scale factor and square it. All right, so that's what these next couple of screens are going to be talking about. Weird, I just had a couple blank screens pop in there. All right, so the perimeters is equal to the ratios of their side, okay? Perimeters are equal. When you're talking about area is equal to the square of the ratio. So perimeters are 1 to 1. Areas are 1 to the ratio squared. So if your similarity ratio is A to B, the perimeter will also be A to B. But the ratio for the area will be A over B squared. So be careful. And then if we added volume in here, this would be A over B. Think about your volume, and that when we're talking about volume, we cube it. All right, let's see here. In this diagram, find the length of PS. All right, so let's find this ratio is 6 to 8. And then we're going to try to find over 20. So 6 times 20 is 120 equals 8x. And take 120 and divide by 8. Whoops, 120 divided by 8 is 15. So x is 15, so SP equals 15. All right, a town plans to build a new swimming pool. Olympic pool measurements are 50 meters by 20, so this is your length. And then the new pool will be similar in shape, will have a length of 40. So the new pool will have a length of 40. Find the perimeter of the Olympic and the new pool. Okay, Olympic pool perimeter is going to be 50 plus 25, and then double it. So 50 plus 25 is what? 75 times 2. So we get this perimeter to be 150. All right, so now we can take this ratio. So we're going from bigger to small. So this ratio is from 40 to 50. So this ratio is 4/5. So the perimeter of this one is going to be 4/5 times 150. So 4/5 times 150, let's see, 5 goes in there. And so this one is going to be, so new pool, I'm just going to call it, is going to be 120. Okay, or could you have found the lengths of the sides? So could you have done 4/5 of 25 and found out the length of this was 20? So 40 plus 20 is 60. 60 doubled is 120. So you can either do it from knowing the perimeters or finding the lengths of the sides, but either way, it's going to be the new pool perimeter will be 120. All right, in this diagram, find the area of DEF. Okay, so what is the scale factor here? So we have to decide, is it 10 to 5 or is it 5 to 10? So it is definitely getting smaller, so we're going to use the 5 to 10, which is the 1/2 ratio. So what did we say if we go from area of one to area of the other? So aren't we going to take 36 times the scale factor squared because we're talking about area? So 36, and we just found out that scale factor is 1/2 squared. So this is going to be 36 times 1/4. So this area is going to be 9 centimeters squared. Okay, so now if you don't quite exactly believe me, then we can find the length of this side. So area equals 1/2 base times height. So 36 equals 1/2 times 10 times whatever that base is. And this comes out to be times 5, 36 divided by 5, I think this was 7.2, which makes this one 3.6. So now if you take 5 times 3.6 and divide by 2, you get 9.